Okie dokie. Hopefully final video. Now, we're going to do some of these together, then you're going to do the rest on your own. Exercises 10 through 15. The arrow notation represents the movement of point P to point P prime on a translated figure in the XY coordinate plane. Describe the movement of the point in words. Basically what they're saying is, we started here, we ended up here, how'd we get there? Okay, so let's do that for number 10 together. Let's pick a smaller font. There we go. Okay, so for number 10, how do we get from -4 to -14? Okay, so we subtract 10 from the x coordinate. And then how do we get from -9 to -16? And 7 from the y. Okay, that's enough. That's how we got there. Now, okay, let's do number, you know what? Let's do number 15. Okay. How did we get from -5, 1 to -9, 2? From -5 to -1, I speak well. -5 to -9, what did we do? We subtracted 4 from the x coordinate. And how do we get from 1 to 2? That's an easy one. We added 1 to the y. Everybody agree? Okay, I agree. Now I want you guys to pause the video and try the other ones and show them to us, okay? All right, so give you a couple of seconds to pause, take your time, and then come back, okay? And I'm not going to do them here. We will do them together in class if you need it, okay? Now, you want to move a figure 3 to the left and up 6. What do you add to the x coordinate? Okay, remember x coordinate. Okay, and in the words of Ms. Breland, y up and down, y up and down. So this is the x-axis, this is the y-axis. Okay, so if we're adding something to the x-axis, okay, it's going to be right or left. All right, so you want to move a figure 3 to the left. So what are we going to add to the x? We're going to add a -3. Did all of you get there before me? Okay, we good? Okay, you could say subtract 3 as well. I would mark that correct. But they said add, so we said add. All right, now we're going to look at some of these. Okay, and again, I'm making them bigger. In exercises 22 through 25, find the length of the translation. Okay, first we're going to do the distance formula. Okay, the distance formula, I will write it for you. Although, okay. D equals, all right, I don't think that you've learned this before, so I don't quite know why they're throwing it in now, but they are. And we can do anything we want. Okay, so the distance here is x2, and this is just position, minus x1, and then the whole thing squared, and I will show you how to do this in the calculator, plus 1 squared, hello, plus y2, again, just position, minus y1, whole thing squared. Okay? Okay? So, point A is translated 5 units horizontally. Okay, horizontally, right to left. And 6 units vertically to point A prime. Now I will show you the distance formula, but first we're going to be sneaky. Sneaky is fine. It's a different strategy. All right, I'm just going to pick any point. Okay? I am going to pick any point and I'm going to label it A. Okay? We're doing number 22 right now. Okay? And now I'm going to move it -5 units horizontally. So that's horizontals right to left. 1, 2, 3, 4, 5. And -6 units vertically. 1, 2, 3, 4, 5, 6. Oh, look at it. Ends up on the line. That's fine. All right. And then I would basically have to measure the distance. But there might be a nice sneaky way to do it. If we can turn this into a right triangle and use the Pythagorean theorem, we'll have it made. Okay, and I think you guys have heard of the Pythagorean theorem. Not 100% sure. Okay, I'm going to draw in some more lines. All right, oh, badly. All right, I'm going to count. So this is 1, 2, 3, 4, 5, 6. Okay, the length here is 6. The length here is 1, 2, 3, 4, 5. The length here is 5. Okay, so the distance, okay, if you remember, the Pythagorean theorem is a squared plus b squared equals c squared. So we can do that in the calculator. So if we do 6 squared plus 5 squared is going to equal this length right here squared. I'm going to write equals c squared. Okay, 6 squared on your calculators or in your head is 36. 5 squared is 25. And we're going to leave this in radical form because it's going to be a nasty one. Okay, 36 plus 25. 25 plus 30 is 55. 55 plus 6 is 61. So the length of this segment right here is the square root of 61, which we would have found that in the distance formula as well. And we're leaving it like that. Okay? So find the length of the translation. You can do this in your calculator. We can leave it as radical 61, or you can simplify it in your calculator. I am so leaving it. Okay, let's try number 23. This video is going to be a little bit longer, but we'll have to survive. All right, so let's pick a point A. I'm going to pick this right here. This will be my point A. Okay, it's translated 3 units horizontally. Okay, so notice it didn't say -3. So it's going 3 units. 1, 2, 3. And -3 units vertically. 1, 2, 3. So this is our A prime. Okay, again, I'm going to do what I did before because I think it's easier, but I will show you the distance formula eventually. All right, and I am going to draw the lines again for the right triangle. Okay, so I'm going down 1, 2, 3. I'm going over 1, 2, 3. Okay, and again, a squared plus b squared equals c squared. Okay, 3 squared we know is 9. Okay, so we have 9 plus 9 equals c squared. Okay? And then 9 and 9, of course, is 18. The square root of 18. All right, c squared. All right, we can write the square root of 18, but I can break 18 up. This you should remember from algebra. 18 is 9 times 2. Okay, the square root of 9 is 3. So I'm going to pull out the 3, and here the answer is 3 radical 2. Now, if you are brave enough to try this on your own, try number 24 and number 25. If you're not brave enough, don't worry about it. Don't sweat it.